In the previous lesson, I mentioned that we'd be learning to solve quadratics in three different ways. In the previous lesson, we learned to solve quadratics through the square root method, but that only worked for certain types of quadratics that satisfied the condition of having x only in one location or being in vertex form. We're going to discuss the second method in this lesson, and we're going to be solving by factoring. So what is solving by factoring? Well, the first thing I want you to understand is that factoring is distribution backwards. As an example, we have x minus 5 times x plus 2 equals 0 right here. To distribute, if I wanted to put this in standard form instead of in factored form, I would just take x times x, which is x squared, x times 2 is 2x, negative 5 times x is negative 5x, and negative 5 times 2 is negative 10, and all this still equals 0. Combining the like terms would produce x squared minus 3x minus 10 equals 0. So that's distribution. The process of factoring is doing what we just did here backwards, going from this point back to that point. The question is, how do we do that? Well, in an example where the coefficient in front of the x squared term is a 1, it's a fairly simple process. It may take some thinking, but the process is decently simple. We want to go from standard form here back into factored form, which means we want to put it back into those two binomials. We call them binomials because each of them have two terms in them. But how do I go backwards? What's the process? Well, in order to go backwards, the first thing I think about is the x squared. X squared. X squared is made by doing x times x. So the first term in each of these binomials is simply an x, because I know x times x is x squared. Now, what are the values that go here and here? That's where it gets a little bit more involved. What we have to do is we have to start with our last value here, the constant, negative 10. And what we want to do is we want to ask ourselves, what combinations of numbers multiply to negative 10? Well, 1 and negative 10, negative 1 and 10. 2 and negative 5, negative 2 and positive 5. Each of these multiply to negative 10. However, I've got to pick which one of these pairs not only multiplies to negative 10, but now we look at the middle number, the coefficient on the x term, and which of these pairs that multiply to negative 10 also add to negative 3. And that would be the 2 and the negative 5 right here. So I know that the numbers here are going to be positive 2 and negative 5. You'll notice that this takes us right back to where we started up here, back to x plus 2 times x minus 5 equals 0. Now you'll notice I wrote them in the opposite order as up there, but multiplication is commutative, which means order doesn't matter. So I could write the x plus 2 binomial before the x minus 5, and it's fine. It's still the same thing. So the question is, how does being in factored form make it useful for us to be able to solve the equation? And that has to do with the zero product property over here. The zero product property says if a times b equals 0, then either a equals 0 or b equals 0. In other words, if I have two things that equal 0, one of them better equal 0 in order for the product to be 0. So what we can do is we can look over here and see I've got two things multiplied together equals 0. That means either the x plus 2 is equal to 0 or the x minus 5 is equal to 0 in order for their product to be 0. Now to figure out what x is, think about what value of x would make this equal to 0. Or you can just simply solve both of these really quick. Subtracting 2, I get x equals -2. So x equals -2 is one of my solutions. Over here I add 5, and I get x equals 5. So x equals 5 is my other solution. Because you can see that the -2 would make this first binomial 0, and the 5 would make this second binomial 0. So these are the two values that are solutions to my equation. Now keep in mind, factoring only works if it's equal to 0, if the factored form of the equation is equal to 0. So let's try factoring again. Now, the last thing I said in the previous slide was for factoring to work, your equation has to be set equal to 0. Our equation is not set equal to 0, it's set equal to 16. But we can make it set equal to 0 by subtracting 16 from both sides. So that's x squared plus 6x minus 16 is equal to 0. So we know we want to factor it into the two binomials, equals 0 still. And I have an x squared term up front here, so the x squared splits up into x times x, because x times x is x squared. Now I start with the constant value as the next piece, so -16. What two numbers multiply to -16? Well, 1 and -16, -1 and +16. We've got 2 and -8, -2, -8. Or, sorry, -2, +8. Add to negatives, or multiply to -16. I think the last one is 4 and -4. Now the question is, do any of these pairs that multiply to -16 also add to +6? And it looks like we do have one right here. -2 plus 8 is +6. So the two numbers that go in my binomials are -2 and +8. So we now have this fully factored. X minus 2 times x plus 8 is equal to 0. So now that we're in factored form, we can finish solving this by using the zero product property, which says that if I have something times something else, and that those things multiplied together equals 0, one of those things better equal 0. So what makes x minus 2 equal to 0? Add 2 to both sides, I get x equals 2. What makes x plus 8 equal to 0? Subtract 8 from both sides, I get x equals -8. So x equals 2 and x equals -8 are the solutions to this quadratic. So we have another problem here to factor. It actually has a couple issues with it. First off, it's not set equal to 0. So let's make it set equal to 0 by adding 24 to both sides. That gives me 4x squared plus 20x plus 24 is equal to 0. Now, the other issue is that the coefficient in front of x squared is no longer a 1, it's a 4. However, in this example, it's decently simple to deal with, because what we'll notice is that every term is divisible by 4. So what I'm going to do is, I am going to factor a 4 out of every term. If I factor a 4 out of every term, what's left? X squared here, 4 divided out of 20x would be a 5x, and 4 divided out of 24 would be a 6. So I end up with a 4 times x squared plus 5x plus 6 equals 0. What I can now do is just leave my 4 out front here and factor what's left inside of the parenthesis, because now it has a coefficient of 1 in front of the x squared. So this piece in here is going to get factored into the two binomials. So we do this the way we've been doing it. We look at the constant value of 6. What two numbers multiply to 6? 1 and 6, and 2 and 3. Do any of these add to the 5? The second one does, the 2 and the 3. So I know because it's x squared, I've got x and x, and now I know that it's a 2 and 3 because 2 and 3 multiply to 6, but it adds to 5. So it's x plus 2, x plus 3, and all of this still equals 0. Now, the 4 out here really doesn't give us any trouble when we now go to the zero product property, because we're now asking ourselves, now that we're in factored form, what values of x make our equation equal to 0? Well, if this piece is 0 or this piece is 0, who cares if the 4 is here, because 4 times 0 is just 0. So we can still just ask ourselves, what makes x plus 2 equal to 0, and what makes x plus 3 equal to 0? Subtract 2 from both sides, I'm getting an x equals negative 2. Subtract 3 from both sides, I'm getting an x equals negative 3. So x equals negative 2 and x equals negative 3 are the solutions to this quadratic up here. So sometimes remember that you have to look and see if every term has a constant factor in it that you can factor out, like we did right here. We have one more example that we want to take a look at. Thankfully, this example is already set equal to 0, so we're good there. However, our coefficient in front of the x squared term is not a 1, it's a 3. So can we, just like the previous example, factor a 3 out of every term? And unfortunately I can't, because 3 does not go evenly into 20 and it does not go evenly into 32. So we're a little bit stuck here. Fortunately, we have something called the box method for factoring. Here's how the box method works. We're going to create a box and cut it into 4 equal parts. Now in the box method, the x squared term always goes in the upper left-hand corner of my box. So the x squared term always goes in the upper left-hand corner. So a 3x squared goes here. And then the constant term always goes in the bottom right-hand corner. So the negative 32 always goes down here. Now the question is, what goes in the other 2 boxes? Well, the other 2 boxes, the values we get here and here, we get very similarly to how we got the values in the other factoring, except instead of asking myself the 2 values that multiply to negative 32, what I have to do first is I have to take the 3 and negative 32 and multiply them together. 3 times negative 32 is negative 96. So that's the value. Instead of just looking at this value and seeing what multiplies together to equal that, I have to take this first coefficient on the x squared and multiply it by that constant. And that's the value. This negative 96 is the value that I now need to split up. So what 2 numbers multiply to negative 96? Okay. Well, we've got several options. We've got 3 and 32. Does 4 go into that? Let's see, 4 and 24. 4 and 24 goes into that. I believe 8 and 12 make 96. And I believe that 16 and 6 make 96. And I believe those are the options. However, it's negative. So if I know that these are multiplying together to be a negative 26, that one of these has to be a negative. So it's either negative 3, positive 32, or positive 3, negative 32. Same with the 4 and 24. So the question now is, do any of these combinations not only multiply to negative 96, but also add to negative 20? And I think this option right here does. The 4 and 24. I think I'll have to make it a positive 4 and a negative 24. Positive 4 and negative 24 multiplies to the negative 96, because a positive times a negative is a negative. But 4 plus negative 24 adds to negative 20. So those 2 numbers are what I put here and here. And it doesn't matter where I put it. So I'm going to put my 4 right here, and I'm going to put my negative 24 right here. Okay. And realistically, they're multiplying or adding together to get me negative 20x. So both of these will have an x on them. Okay? Now we're really close. Here's what we now do. What we now do is we look in each row and in each column, and we ask ourselves, what is the greatest common factor? If I look at 3x squared and 4x, I notice that both of them have an x in common. And then I look in this row at the negative 24x and negative 32x, and I notice that they both have an 8 in common. But because the value in this box right here is a negative, I know it's going to be a negative 8. Okay? Now I look at each column. When I look at 3x squared and negative 24x, when I look at that in common, I notice that they both have a 3 in it, because 3 goes into 3, 3 also goes into 24, but then they both have an x in them, so 3x. Okay, and lastly, this right column here, I've got 4x and negative 32. I believe 4 goes into both 4 and it goes into negative 32. So a 4 is going to come out here. Now the question is, should it be a negative 4 because the 32 down here is negative? No, because what you do is you simply keep the sign of the box that it's next to. Whatever sign is in each of these boxes here and here, that's the sign that goes here and here with whatever number comes out. So what we now have here, interestingly enough, is our two factors, or our two binomials. I've got x minus 8, and I've got 3x plus 4. So x minus 8 and 3x plus 4 are my two factors, and these equal 0. So we've successfully factored it using the box method, and now we can finish solving since we're in factored form. Here, what value makes this 0? What makes x minus 8 equal to 0? Add 8 to both sides, x equals 8. And then also, what makes 3x plus 4 equal to 0? Well, if I subtract 4 from both sides, that gives me 3x equals negative 4. But then I have to also divide by 3 because of the 3 in front of the x. So x is equal to negative 4/3. So my two solutions are x equals 8 and x equals negative 4/3.